Good morning, guys. I hope that you guys are doing well. We are going to continue with the rest of the notes for your Calculus 5.1. The good news is, like I've said before, we are close to finishing up with all of the notes and new material. Some of this is review, some of the stuff you have seen before, but I want to make sure that you have a real good idea of these concepts. So for this one, when you see the fact that we're solving for the derivative of this, initially you should think quotient rule, and you should also think that you would have to use the chain rule inside the quotient rule, which gets a little ugly. It will get you the correct answer, but I also want to remind you that you can rewrite these as natural logs. So if I take the natural log of both sides, I can rewrite this entire equation as the natural log of y equals the natural log of x minus 2 quantity squared minus the natural log of I'm going to write it as x squared plus 1 to the 1/2 power, as opposed to the square root of x squared plus 1. Side note real quick, x does not equal 2. That simply refers to the fact that you cannot have 2 as a value, or you won't be able to solve this problem. You would get D and E. So that's just kind of a side note that they say, hey, this is assuming that x does not equal 2. In other words, this is a legitimate problem to work. From this point, I'm going to continue going on with my exponents becoming coefficients. So I'm going to move these out front. When I do, I will have the natural log of y equals 2 times the natural log of x minus 2 minus 1/2 times the natural log of x squared plus 1. Now I'm going to be taking the derivative of both sides. Do not get completely bent out of shape of the fact that when I take the derivative of the natural log of y, I am going to get y prime over y, okay? Side note again, derivative of the natural log of x is technically x prime over x. If it's the derivative of the natural log of u, then it is u prime over u. So similarly here, this is going to be y prime over y. And we're just going to kind of leave that alone right now and move on with the rest of this problem. So then I'm going to have 2 times when I take the derivative of the natural log of x minus 2. That is x minus 2 quantity, that's my u value. That's going to be u prime. So I would get derivative of x minus 2 is 1 over the u, which is just x minus 2. Similarly, I would have minus 1/2 times. Well, now when I take the derivative, my u is equal to x squared plus 1, so that is the top. But when I take the derivative of x squared plus 1, I get 2x. So now I can start doing a little bit of cross canceling here. This 2 will cancel here. All right, and I'm still going to have y prime over y at the left. I haven't really forgotten about that. We're just leaving it alone right now. Equals 2 over x minus 2. Okay, so I just kind of combined these 2 times 1 over, you put that over 1 if you want, 1 times x minus 2. And then I have minus x over x squared plus 1. At this point, I'm going to be finding a common denominator on the right-hand side. So I would be multiplying the top and bottom of the first term by x squared plus 1, and the top and bottom of the second term by x minus 2. Okay, I'm going to continue this over on the next page. So that gives me y prime over y equals, and then I have x squared plus 1 times 2 minus x times x minus 2. All over my common denominator, which would be x squared plus 1 times x minus 2. The next goal will be to distribute the numerator, so I would have y prime over y equals 2x squared plus 2, careful when you're distributing that negative, minus x squared plus 2x all over x squared plus 1 times x minus 2. I'm now going to combine like terms. 2x squared minus x squared is my only set of like terms, and that would leave me with just a positive 1x squared. I'm going to bring down plus 2x plus 2 all over my common denominator, x squared plus 1 times x minus 2. And then on the left, I cannot forget that I still have y prime over y. Now we're solving for the derivative here. So what we're actually going to do is solve for y prime, meaning I'm going to move this value to the other side. The way that I'm going to do that is multiply by the reciprocal y over 1. When I do that, that eliminates the y on the left, leaving me with the derivative of y. And I have the value x squared plus 2x plus 2 all over x squared plus 1 times x minus 2. But I'm multiplying that by y. The y value is what you were given at the very beginning of this problem. Y equals x minus 2 quantity squared over the square root of x squared plus 1. And I'm actually going to substitute that back in. When I do, over the square root of x squared plus 1, I'm going to notice several different things, or at least I hope you do. The x squared plus 1, you have a common value, that common binomial in the denominator. So I can actually rewrite that denominator as x squared plus 1 to the 3/2 power. And then I have that x minus 2. Well, this current x minus 2 in the denominator actually cancels with one of those up top. So I could even rewrite this as just x squared plus 1 to the 3/2 power, because technically everything else has simplified out. My numerator that I'd be left with is x squared plus 2x plus 2 times x minus 2. Okay, and this is going to be your final answer. Had you worked this with quotient rule, you would have the same result. It might be written a little differently. You might have everything foiled out, but all in all, those answers would be equivalent. And that's it for this problem.